just waiting for a bit. Cool. Hi everyone, welcome to our presentation for our design project for EEE3097S, a course taken at UCT. My name is Gregory Silva.
My name is Alison Adams.
And today we'll be presenting. Awesome. So starting off with the context of the project, our current understanding of Southern Ocean sea ice dynamics is quite poor, with the temporal and spatial gaps in general season data sets. So with the lack of this environmental and wave data, it's led to a project at UCT, which is generating a tethered measurement platform in order to measure or model some data. Our role in this design is to create a ARM-based digital IP using Raspberry Pi to encrypt and compress the IMU data. Some constraints in the matter of this project. Well, what we need to use ideally is a microcontroller. However, what we only have available to us is a Raspberry Pi, and our course has also given us a Sense hat, which is compatible with a Raspberry Pi. Next, I'll hand over to Alison.
So what we did first is we created a paper design. Basically, what happened was with the project, we got certain requirements that needed to be met. From these requirements, we were able to generate specific specifications, so we knew exactly what to use in our project. We used Asana as our project management tool, and basically this allowed us to develop a timeline from the start of the project to the end of the project, and it made sure that we were actually meeting the deadlines that we needed to meet throughout the project process. We then generated acceptance test protocols. What this means is we had criteria that needed to be met, so we ran different tests on our actual project to ensure that this criteria was met. With this being said, we ran different simulations. So we got a file from our EEE3097 course, and using this file, we used the data that was on the file, and we ran different tests on the compression block and then on the encryption block. The encryption block followed the compression block. Thus, we used the compressed file in the encryption block. What we then did was we made sure that it met the criteria. It was encrypted, it was compressed. We then decrypted and decompressed that same file and compared it to the original to make sure that no data was lost in between. We then did different testing when we actually got our Sense hat. So what we did was we made sure we could extract data from the IMU module on the Sense hat. We then used that data to do the same tests on the same compression block and encryption block, and we then compared the data with the original file to ensure that it was actually working. We then found that the Sense hat data is the same as the raw data that was given to us, so we knew our algorithm was working. I'll now give over to Greg to actually run our algorithm.
Awesome. So if I just end this here and share my screen. So if we look at the first files that are in this directory, we see that we've got a file here called test.py. So if I run Python 3 test.py, and if I place that into some file called my data.csv, and if I run that for about 3 seconds, so 1, 2, 3, and just run that, so you'll see that there's going to be a file here called mydata.csv. So if I go into that, you'll see that there's some data here that was gathered from the IMU, that's over here. So if we just exit that, and now we run our compression algorithm, Python 3 compress, it's going to ask us what kind of file do you want to compress and encrypt. So we say mydata.csv. So if we run that, we can see that there's about a 58% compression ratio, and it indicates that there's no difference between files. So if we now look at all the files that we've generated, we see we've got a mykey.ekey here, which is basically the key used in the encryption. We've got a final decrypt here, a final encrypt, and if we look here, we've got a raw data.csv. So just looking at original, this is the original file that was called mydata.csv, the program renamed it. Then we've got raw data.csv, which is the file taken after compression, encryption, decryption, and then decompression. And if we look into this file called raw data.csv, we should see that it's pretty much exactly the same data. And once again, because it says no difference between files, no differences occurred. So all of this shows that our project has been successful. and we would like to thank you for this presentation.